Okay, again, when you're taking the limit of a rational function like I have here, what I need to do is first test to see if my numerator and my denominator are 1, both continuous, and 2, is my denominator equal to 0 at the x value that I'm evaluating the function at, or evaluating the limit here at. So what I'm going to do is I'm going to take a look at the top. So I'm going to ask, is x squared plus x minus 20, is that guy, call that f of x, is it, I guess I don't even have to say it, do I here? Is it continuous? Well, sure it is. This right here is just a quadratic function. We know that polynomials are continuous. So the answer is yes. Okay, so that's good. So we've checked that guy off. Now let's ask the next question. Is x squared plus 6x plus 5 equal to 0? Oops, not equal to 0. We'll just call it g of x. It doesn't matter what we call it. Is that continuous? And the answer is yes, it also is. Okay, because again, it's a polynomial function. Okay, and polynomial functions are continuous. So both these functions are continuous. Now, the next thing to check is what is the limits as x approaches -5 of g of x here. And remember, our g of x, that's the same thing as saying what is the limit as x approaches -5 of x squared plus 6x plus 5. So we test this guy out here. And what we want to make sure is that this is not equal to 0. So we do not, I'll put that here, do not want 0. If we do get 0, then we've got to do the replacement rule. So let's check this guy out. When I plug in -5, I get 25 minus 30 plus 5. Well, that's going to be 0. So since the denominator here is 0, okay, we have to use the replacement rule. So here's what we're going to say. We're going to say that x squared plus x minus 20 over x squared plus 6x plus 5, that is definitely equal to the following. So I'm going to go ahead and I'm going to factor the numerator and the denominator. And what I'm looking for is like terms, right? Yeah, like terms. I'm looking for things to cancel out, right? So I've got this top is going to be x and x plus 5 minus 4. And the bottom is going to be x and x plus 5 plus 1. And then notice that this guy and this guy, we can cancel. Now we have to be careful. So what I'm going to do is I'm going to say that, yeah, they're roughly equal to one another, but they're not quite the same. So I'm going to say that this guy over here on the left is equal to this guy on the right as long as x is not -5. Because over here, when x equals -5, this guy right here is, I get out that is undefined. However, when x equals -5 on that guy, I get out -5 minus 4 over -5 plus 1, which is -9 over -4, or 9/4. So they are not equal to one another. This right here and this right here are not equal to one another, but they are equal to one another under every single number except for -5. That's not an issue, because when we look at limits, we only look what happens to the function close to -5, not at negative 5. That's the important part. Okay, so what we can do is we can say the following. We can say that the limit as x approaches negative 5 of x squared plus x minus 20 over x squared plus 6x plus 5 is equal to the limit as x approaches negative 5 of x minus 4 over x plus 1. Because in both of these cases, x is not equal to negative 5, because the limit only concerns itself with values near negative 5 and not at negative 5. So this can be replaced with this, and then we know that this, and you write all this down, this is equal to the limit as x approaches negative 5 of x minus 4 times, I'm going to have to write it right down here because I ran out of room, as x approaches negative 5 of 1 over x plus 1. And so that is equal to negative 5 minus 4 over, well, I shouldn't even write over. I should write it like this. It's equal to negative 5 minus 4. That's this guy right here, times 1 over negative 5 plus 1. So that'll be negative 9 times 1 over negative 4, which is equal to 9/4. Again, we need to see all of this. This is how you're computing the limit. Okay? And so our answer is 9/4. But I don't want to see on an exam, do not just put that guy. If you do, no points. You need to have a clear explanation that I can follow all the way down. Now remember, this would be considered, this is my scratch work. I would write it down nice and neat. Okay? On the exam, I would say something. This is what my exam would look like. So that's scratch work up there. Here's what you would show. You would show the limit as x approaches negative 5 of x squared plus x minus 20 over x squared plus 6x plus 5. Okay, that is equal to the limit as x approaches negative 5 of x, what do we have, x minus 4 over x plus 1. Okay, that's true. And it would be nice if you would say that this is a replacement. Okay, so replacement, though not necessary. Okay, and then we would say that this is then equal to the limit as x approaches negative 5 of x minus 4 times the limit as x approaches negative 5 over 1 over x plus 1. This is by the product rule. Okay, and then that is equal to, let's see here, negative 5 minus 4 times 1 over negative 5 plus 1. And now it's good here to say something like, because x minus 4 and x plus 1 are continuous. Okay, so that gives me a justification for why you wrote that, how you knew you could go from here to here. Now we evaluated our limit values, and again, we come up with 9/4. So I would like to see this written out very nicely. Again, if you just jump to this, no points.